Hello students, welcome back to JJ's physics class. In the last class, we have discussed about the area enclosed by velocity time graph for a car moving with uniform velocity. Today, we are going to calculate the area enclosed by velocity time graph for a car moving with uniform acceleration. Let us start. The question here is calculate the area enclosed by velocity time graph for a car moving with uniform acceleration. As you can see here, time is given in seconds starting from 0 to 30 seconds. Velocity in meter per second, that is from 0 to 15 meter per second. That means when time is 0 second, the velocity also 0. But when the time is at 5 seconds, what happens to the velocity? Velocity reaches to 2.5 meter per second. So let us start plotting the graph. For plotting graph, we need the graph sheet. We have to decide what is there on the x-axis and what is there on the y-axis. So the two quantities are time and velocity. As we know that time is an independent quantity, but velocity is dependent on time. So independent quantity is always taken along the x-axis and dependent quantity is always taken along the y-axis. Time in seconds is taken along the x-axis and velocity in meter per second is taken along the y-axis. So we have to choose the scale on x-axis now. So we have time starting value 0 and maximum value is 30 seconds. If you take x-axis 1 centimeter as 5 seconds, so we have 0, 5, 10, 15, 20, 25, 30, etc. on the x-axis, and velocity varies from 0 to 15 meter per second. So we have to choose the scale as y-axis 1 centimeter is equal to 2.5 meter per second. So 1 centimeter means from here to here. 2.5, next is 5, 7.5 and so on. Next we have to start plotting the graph. So we have time 0 and velocity also 0. So we have time is 0 and velocity is also 0. The first point is here. Next is when time is 5 seconds, velocity is 2.5 meter per second. So time is 5 seconds and velocity is 2.5. So draw a line from x-axis and draw a line from y-axis where both the points will meet. There you get the next point. Next is 10 and 5.0, that is time 10 seconds and velocity 5 meter per second. Next point is here. Next is 15 and 7.5. So 15 and 7.5, next point is here. Next is 20 and 10. So here 20 is here and 10 is here. Where both will meet, you get the next point. Next is 25 and 12.5. So next point will be here. Next is 30 and 15. So the last point is 30 and 15. So we have 15 at this point. Next, you have to join all the points so that you get a straight line like this. We are going to calculate the distance traveled by a car between time interval t1 is equal to 10 seconds and t2 is equal to 25 seconds. So we have choose the time as t1 is equal to 10 seconds and t2 is equal to 25 seconds. So what do we here is we draw two lines to the x-axis where they meet at 10 and 25 seconds. As you can see here, the area under this line is not a triangle or a rectangle, but it is the combination of the two. So we have this shape here A, B, C, D, E. So we have divided that into a triangle and a rectangle. So triangle ADE and a rectangle ABCD. In the last class, we have learned that the area under velocity time graph gives the magnitude of the displacement or distance traveled by a body. So definitely the area under this A, B, C, D, E will give you what? The distance traveled by this car. How do we calculate the distance traveled by a car between the time interval, that is from 10 seconds to 25 seconds, or from the graph? We have the distance traveled by a car is represented by S. So S is representing what? Distance. Can be calculated as what? Area ABCDE, that is ABCDE. Now what is area ABCDE? So it is nothing but area of this rectangle ABCD plus area of the triangle ADE. ADE. You must also know that AD is equal to BC and AB which is equal to DC. That is AD which is equal to BC and AB which is equal to DC. Now we calculate the area of rectangle ABCD is length into height. BC into AB plus area of triangle, as we know that half into length into breadth. So half into AD times DE. DE. So what is BC here? So BC is nothing but AD, which is equal to difference between T2 minus T1, that is 25 minus 10. So that is nothing but 15 seconds into, what is AB here? AB is this distance. 5 minus 0, which is 5 meter per second plus half times, what is AD here? AD is again BC. So it is 15 seconds times, what is DE? DE is this distance, that is 12.5 minus 5. That gives you what? 7.5 meter per second. If you calculate this, 15 into 5, which gives you what? 75. Second will get cancelled. So 75 meter plus half times 15 into 7.5 meter per second. So that you get it as 112.5 meter. Second will get cancelled. So what you get here? 75 meter plus 112.5 divided by 2. So what you get here? It is 56.25 meter. The final answer you get it as 131.25 meter. So that is the distance of the car between the time interval. T1 is 25 seconds and T2 is equal to 10 seconds. So this is how we get it as 131.25 meter. So we have learned that the area under velocity time graph gives what? The distance travelled by the car. Another way of calculating the distance travelled by a car is nothing but the area of the trapezium. So this is the shape of trapezium, that is BAEC. How do we calculate the area of trapezium BAEC? The formula is half times sum of parallel sides into perpendicular distance between them. So the formula is here sum of parallel sides. What is parallel sides here? AB and EC into perpendicular distance between them. So perpendicular distance is what? BC. So how to calculate? So S is equal to, what is BA here? BA is nothing but the distance, that is 5 minus 0 meter per second. So that is 5 meter per second plus, what is EC here? EC is this distance, 12.5 minus 0, that is 12.5 meter per second. This is the sum of parallel sides into perpendicular distance. What is perpendicular distance here? 25 minus 10, that is 15 seconds divided by 2. So 17.5 meter per second into 15 seconds. This whole thing divided by 2. So what is this? 17.5 into 15, which is equal to 262.5 divided by 2 meter, which is nothing but 131.25 meter. Whatever method we follow, we will get the same answer. In the previous case also, we got it as 131.25 meter. So we have the final answer as 131.25 meter. So the area under velocity time graph gives the distance or magnitude of displacement moved by a car in a given interval of time. Thank you.